Good, hello everyone. Welcome to the Tech Talk Thursday. I'll give you a short intro, and I'm already apologizing if we have technical issues because this is the first time that we stream that on YouTube, so knock on wood, it works. So, afterwards we have the first presentation of Erik Funk. He's talking about Windows and Linux and how you can develop like a pro on Windows. And afterwards, Tobias Brunner of Vision will give an intro how they manage a fleet of Kubernetes clusters. And afterwards, for the ones that are here, we'll have some snacks and beer. And for the ones who take part remotely, please write your questions in the comments. And we'll record the sessions, of course, and we'll do some cutting, cut out the unnice stuff, and present it on YouTube. Good, and for our next events, on the 10th of November, we'll have the Google Cloud Meetup here. This is a sister event, also organized by us. And then afterwards, later on the 26th of November, we'll have the Tech Talk, the next one, earlier than planned, because last week we had some problems that a presenter left, and then I made a post on LinkedIn, and we had so many replies that we already were able to fill another Tech Talk. So thank you very much. And if you want to be a speaker or so, please approach me. That was it from my side. So handing over to Erik.
Thanks for the introduction, Tom. I'm Erik. I work here at 9. I'm the lead architect. And today, I want to talk about how to develop like a Linux professional Windows. It sounds a bit strange. First of all, I'm not a Windows fanboy. So I have a Mac at home. I work with Linux for a long time, but there has been some remarkable developments in Windows that made me think about doing this talk today. Let's start with a bit of history. I mean, Windows always, to the success of the operating system, they had a massive development community. But it was mostly like active within the Windows ecosystem, which traditionally meant like Visual Studio, .NET, Visual Basic, WinForms, all that stuff that gives you the shivers today. There was always some kind of, well, a little bit of cross-platform development, even back then with Java, JDK, Eclipse. But generally, Microsoft didn't really like Linux. Steve Ballmer even said like Linux is like a cancer. So not really a good relationship. But of course, you know that man. They love developers. Yep. Well, apart from that craziness, you generally had a really bad experience of running and developing applications outside of the Windows ecosystem. I mean, there was like a Python port. Some people even like compiled PHP to run on IIS. There was VirtualBox to run virtual machines, Cygwin, but as I said, for me, it was not a good development experience. And as a result, many people switched to macOS. Because like that was how Windows development looked like. And on macOS, you had like PHP Storm, or you had like Brew. You can install all the Linux packages you want to develop with. So all the good stuff from the Linux world on the Mac. But then came a very interesting move from Microsoft. And with the new CEO, Nadella, this guy said something really remarkable.
And so the way we've gone about that is on multiple layers. So for example, the Microsoft Cloud is ready for any device. You can be on iOS or Android or Windows Phone and use the cloud for your application state, for your notification, and as a backend for every application that you build across those devices. We are also a cloud that supports any OS on any container technology. So we support both Linux and Windows Server. This is something that I want to just make sure I drill home. Microsoft loves Linux. 20% of Windows, 20% of Azure is already Linux.
So that was quite remarkable, in my opinion. Because what made them suddenly say they love Linux? Well, it was obviously their shift from a pure desktop OS to cloud services, to platform as the cloud services. And obviously, we all know the cloud runs on Linux. Yeah? And Microsoft did not only say, okay, we're going to run our cloud on Linux, they also suddenly became very interested in open source technologies. And they used a lot of open source technologies, in my opinion, to just catch up. And they did not only use it, they also contributed towards open source as a return. So they developed a lot of tools. They suddenly provided Linux, contributed towards the Linux kernel. Was really a radical change there. And a little bit later, actually, they did something crazy and some really unexpected as well. They released the technology they called Windows Subsystem for Linux. In that version, you could pretty much run Linux straight on your Windows machine. And in this early version, they basically built something where they translated all this Linux system calls onto the Windows kernel. And this move already allowed you pretty much to install Ubuntu on your Windows machine. You could run your Git, you can run your Node.js. So pretty much every package on Linux could run on Windows. And just this year, they released the next iteration, Windows Subsystem for Linux 2. And there they did a completely redesign. What they did is they don't longer translate the system calls. They actually run a virtual machine, and it's like a real Linux kernel now. And they had this advantage of performance, integration. I'll go more on this later. What they didn't have though is Linux on a Windows PC is still just a command line. There's no GUI. I mean, the GUI is Windows desktop. And yeah, by having that Windows Subsystem for Linux, you pretty much had all the tools from the Linux world right on Windows. And what was also interesting, and after this I jump into the demo part, is that Microsoft become really active actually in the providing of development tools itself. I mean, how many of you guys use Visual Studio Code? Oh, quite a few. So that's a Microsoft product ultimately. I mean, you probably not use it on Windows, you maybe use it on Linux or Mac, but still, made by Microsoft. TypeScript, they push forwards, and also, of course, I mean, they run GitHub today, something every developer uses on a day-to-day basis, and yeah, you might also occasionally go to LinkedIn, it's also Microsoft. So they kind of embrace the whole developer community, and in my opinion, it gets harder and harder actually to hate those guys. Quite remarkable. So let's start into demo time, but before that, I just have to show you another clip. Okay, enough of that. No, just kidding. Remarkable, okay. I want to show you quickly how you would work with Ubuntu today in a Windows environment. So installing Windows is not just like downloading some ISO or mounting stuff or anything. It's actually very easy to integrate it because they go as far as you go to the Windows store, you search for Ubuntu. I don't know why it's in French, my Windows store, but never found out how to change it. And there's Ubuntu. There's not just one Ubuntu. There is 2 versions. And I'm not going to do it now, but pretty much you press install, you press launch, job done. And as a result, you have this. You have an Ubuntu shell. You can also install Debian, or you can install SUSE or whatever, but it's pretty much there on your fingertip. And now you can already start to develop. I mean, you can install Git, you can install Node.js, you can install an Apache, whatever you want. So that's quite great. And the good thing is also they did some very nice things for you. For example, it's too small now, but they actually mount your C drive automatically in Ubuntu, and in reverse, they give you direct access to the Linux file system via Windows Explorer. So if you ever fancy of editing your, you know where I'm heading, your bash RC with Notepad, just kick off, do it. It's possible. So the integration works both ways. It's really nice. It might sound a bit strange, but it helps me. Like sometimes you get an asset or a package or something, so you can actually work really seamless with your Ubuntu installation and your Windows desktop. Because the rest of my desktop, as you can see, still runs on Windows. Yeah. Same for networking. I mean, if you open a service on a specific port, you can access the service in Chrome, whatever, a web server, a database. It's all very, very seamless. So this is quite cool. Next thing, Docker. I mean, development without containers. You can still do it, but it's kind of also a requirement to install Docker. So a question for the audience, where would you install Docker?
Is this WSL 1 or 2?
2.
Okay, so in WSL.
Correct. You would do it in Windows. You could theoretically not install it in Linux, but you wouldn't do that. You would do it on Windows.
So when you're running 2 Hyper-V VMs, one for WSL and one for Docker.
This is correct. So you can see that actually here down here. It's maybe small, but there's one for Docker. So you downstall the installer, you run Docker, and just gonna launch Docker Desktop now. And thanks for the question, because that's something I want to show straight in the beginning. So for the demo gods are with me, Docker is starting. There you go. You would have to double check that you use the WSL-based engine here. And you would also check underneath WSL integration that you install that for your Linux distribution. Why are you doing this? By doing this, actually, there's some black magic happening behind the scenes. But as a result, you can pretty much access Docker straight away from Ubuntu. But you don't need to install any Docker stuff. The same for kube control. Yeah, there's nothing now. Or Docker Compose. That all comes from the Windows installer, interesting enough. But it's convenient. It's because, yeah, there's other ways to do it, but it's convenient, especially as a beginner. Yeah, you all know got it. I just, for the sake of the demo, I'm just gonna do a little Docker run here. So I have my Nginx running on port 80, and I go to my Chrome on Windows now, obviously, and yeah, what a surprise. I mean, it's running there. So it's quite nice because, yeah, it's very, very nicely integrated. You can really work with that if you have a Windows, if you're forced to use a Windows desktop. I'm not forced, by the way. It's my own choice. So, especially if you're a beginner, you might find it useful to see like a graphical user interface for your Docker stuff from time to time. It's there, but same time, the pro, just as usually, Docker PS. So there you go. And again, I mean, yeah, there's no magic. If I kill that here, yeah, it's gone. Easy. So because it basically shares the whole thing. So this is quite nice because like for stuff you don't necessarily want to install it on Ubuntu, you have the Docker desktop for Windows, and you just spin up your images there and you do your development. So that's very helpful. Next, Visual Studio Code. We already said it. It's also a tool that evolved quite a lot over the years, and it's being used by many developers today. And there's actually also good support for Windows now. Funny thing now, as you can see in default, it still boots like into this Windows mode. So in theory, I could now develop some C# code or whatever. I'm a Windows developer. But if I want to switch in a different world, if I want to develop Ruby or Go or whatever, I have this little connect thing here. And a new thing starts. And it's connected to my Windows subsystem for Linux for Ubuntu. And if I have a terminal now, that's a bash. There you go. To be honest, I rarely boot into the Windows mode. I always connect like to my virtual Ubuntu machine there. So by that time, if I work with some code, I'm pretty much in the Linux world, or Unix world, or Mac world, or whatever. It's super easy. If you open a folder, that's actually your home folder. So they set the root wherever in which mode you are. You're either on your Windows Explorer or you are in your Linux home directory. And there are some useful plugins. For example, the WSL plugin. So here you can list all your projects you have checked out on Ubuntu. And yeah, even like if you open recent, you can see there is a little remark here, Windows Subsystem for Linux. So you can actually see if that's a project that runs on the Linux virtual machine or a project that is native on Windows. So that's quite cool. I have to check the time. Yeah, that's good. There's also a Docker plugin. I don't know. I don't use it a lot, but in theory, you can also get a list of your images or start a quick container from Visual Studio Code.
But in this case, your extensions on VS Code work in Linux mode. So path completion and Python don't care what you have installed on Windows.
This is correct. And this is exactly where I wanted to go. If you list your plugins, you can actually see there is local installed plugins and remote installed plugins. So if you would install, for example, a C# plugin, you could have the choice. You can have a local .NET Windows, and you develop C# in Windows mode, or you would install the C# plugin on the Linux virtual machine, and the plugin mode is then in Linux mode. So that's quite interesting. In theory, you could also have like another SUSE Linux or something running in parallel, something completely different, but that's enough for most of my cases. But it works really nicely. Yeah. It's really well integrated, and as a developer, I don't really want to care about that. I want to start my IDE, I want to check out my code, I want to use my Git, and I want to work with the code. The same is like if you have like a Go project, for example, it doesn't really matter. You set a breakpoint there, and you can debug your code. You can step through all the development. There's no difference of developing natively with Visual Studio Code on a Mac, for example. It just works, which is nice. I really like that. And one thing I forgot earlier on, I actually think, for example, like the development or Docker on Windows is actually faster than on Mac OS X. They have a better way working with the file system. I mean, there's tweaks around it, but I'm pretty sure it feels a bit snappier and a bit better than on Mac OS X. I don't have the comparison to Linux and Docker, but Windows is definitely better than Mac, in my opinion.
Well, we can't hear your fans from here, so I guess you're right.
I have no fans. I'm my own best fan. No, just kidding.
Fans, maybe.
The Mac fans, they're like, boo! No, just kidding. Let's go back to presentation. So we've seen Visual Studio Code, and now we've got 10 minutes left. And as a last thing, we want to play with some Kubernetes. And that's also very easy now. because we have already seen there's like kube control is already included in the whole thing, and we've got Docker, and there's an easy way to spin up a cluster. And that is interesting because what we find out, for example, we do like the Kubernetes Academy, and some people turn up with a Windows laptop, so we have a problem. So this way, if the guys are actually developers, if they have admin rights, they can install Docker and they can do some Kubernetes development on Windows as well. You don't necessarily need a Linux or a Mac OS. Yeah. So let's go to this one, and I have to say I'm not a Kubernetes professional, but there is this tool Kind I have installed. Autocomplete says delete. This is from the test. So Kind create cluster. And that will take some time, I guess. Doing its magic. That's a good thing. I can actually show you the Windows Task Manager. It's also something useful what's going underneath the hood. So there's VMMX. Apparently this thing seems to be like the virtual machine there. So it uses some memory, CPU, it's busy now setting up Linux. That's the virtual machine. Our one is VLC streaming. And yep, there we go. At least some progress. Something is running there. Kubernetes control plane. It's also there. Okay, there's not a lot there, but you get the idea. So it's very easy. I mean, all I've did pretty much, I go to Windows Store, I install Ubuntu, I install Docker Desktop, I ensure it's using Windows subsystem for Linux. I did not install any kube control, I did not install any Docker binaries. It's just basically there, and I can start working with that. Like I say, I mean, there's still good reasons to use a Mac or to use a Linux, but in my opinion, this is something which is really, really helpful for developers. And it also like kind of opens the door towards all those technologies, because there are still many people who use Windows, but by using the Windows subsystem for Linux, by making all the Linux so accessible for those developers, I think that's a big opportunity. And now I'm faster with my talk, so we have a bit of time for questions, if you like.
There's one
Tom.
comment from online. Sebok says, as a Mac fan, this is nice to know that the file system is that fast. Makes me want to try.
Yeah, go for it. Go for it. Any other questions? You?
Have you ever tried the development container feature of Visual Studio Code?
No, I did not. No. What is it? Is it something Docker-like, or?
Yeah, it's like you define a container where all your development tools are installed inside.
Yeah.
And Visual Studio Code actually connects to the container that is like,
Yeah.
it's just another remote end instead of connecting into a Linux, it's
Okay.
connecting into a container.
Yeah, I know. I did not know that there is actually something from Visual Studio Code, but I give you like one example. For example, we work a lot with Ruby in this house, and I did not install the Ruby on my Ubuntu or my Windows or whatever. I run the Ruby Docker image, and I boot straight into the console of Ruby, and I work with that. But if there is an integration for Visual Studio, which basically skips that job of spinning up the Docker image, you can tell me after the talk. Sure. I'm interested in that.
Sure.
Any more questions? No? guess in that case we can hand over to the next speaker. Tobias. Thank you, guys.
It looks like I'm ready. It just took a few minutes. Okay. Good. Hello, everyone. My name is Tobias. I'm here to talk to you a bit about Project Syn. I want to introduce it to you. And yeah, I work at Vision. I'm a big fan of Kubernetes. You might see that on my t-shirt. I was at KubeCon last year. Sadly, it didn't work out this year, but who knows how it looks like next year. But you've seen Kubernetes before on this Windows desktop. It was a single node Kubernetes cluster. But now we want to talk about a fleet of Kubernetes clusters, and we will see how Project Syn can help you here. You might wonder, why Project Syn? Well, what's the name behind it? And my company is good in naming, so we've chosen also a good name for this project, and at least Syn can be used in different constellations like synthesize, synfaction, or whatever you can imagine doing with this word. So, but the main idea was if you translate this from Swedish to another language, it's just Vision. So Project Syn is an integrated set of tools which helps you managing a fleet of Kubernetes cluster, and we will see in the next few slides what this means actually. So why do we even need such a thing like Project Syn? So if you ever had to manage a huge amount of Kubernetes clusters, like hundreds, then you might know it's not that easy to keep track on what's going on so many clusters. And we thought, why not automate that? Because that's what we do all day. Some questions you might ask yourself if you manage an amount of Kubernetes clusters. So for example, where are all my clusters? And to whom do they belong? They might belong to a customer, to a team, or whatever. They might be in the cloud or on your desktop or wherever else. You might have very many different Kubernetes flavors around, like EKS, AKS, OpenShift, Rancher Kubernetes, whatever. And you want to know which one of your Kubernetes cluster has which flavor, for example. Then how do you bring configuration onto your Kubernetes clusters? That's mainly the same issue you have when you manage a huge amount of Linux servers. You also have to somehow want to manage them all the same way. And how can I have a common configuration across all my Kubernetes clusters? Also the same questions you might have managing a fleet of Linux servers, like setting the NTP server on all my Linux servers to the same value. And more like a philosophical question, what actually does managed mean for a Kubernetes cluster? So Project Syn tries to bring answer to all these questions and help you to solve these problems you might have. Let's dive into a list of features which Project Syn has today. So first and foremost is the multi-tenant and multi-cluster management feature. So it's actually the inventory of your Kubernetes cluster. So it knows where they are, to whom they belong, what kind of Kubernetes clusters they are, and so on, and brings the initial automation stuff you need to manage all these Kubernetes clusters. Then it brings, of course, GitOps. That's the buzzword of the day. So Project Syn helps with the full automation around GitOps. And it uses as a main tool Argo CD to apply configuration onto your Kubernetes clusters. It also helps to actually make a Kubernetes cluster Project Syn managed. So you can compare this to install the Chef agent in your Linux server, install the Puppet agent in your Linux server, and so on. And as soon as you have this agent installed, the server gets automatically managed. And the same here, as soon as you install the agent of Project Syn in your Kubernetes cluster, it automatically gets managed by the tooling around it. And it tries to do that in a securely fashion so that you cannot install the agent in a cluster which you don't have access to. Then it helps you with configuration management. So as it knows all about your Kubernetes clusters, where they are, to whom they belong, and so on, it tries to give you tooling to distribute configuration, generate configuration, depending on the flavor or on the location of a Kubernetes cluster. And it does this by using a hierarchical configuration structure. So many of you might know Puppet, and with the Hiera configuration backend, it has a similar approach to this. Also, it brings reusable components, so we think it doesn't make sense to write such configuration management for, let's say, the Nginx ingress, the metric server, and so on, again and again. So it's a component-based, which can be reused by several different Kubernetes clusters and users of the project. Also, the project itself brings a default toolset. That means it also already brings a huge catalog of such reusable components with it. Also, these components, they are automatically maintained by Renovate. That's a bot which tracks upstream versions of tooling and makes sure that all these components are using up-to-date software. Another issue what you might have when you're working with Kubernetes clusters is how you securely manage your secrets on a cluster. And Project Syn helps you here as well by leveraging HashiCorp Vault and Capitan as the configuration generator in the backend. So, but how does this all work? That was a lot of buzzwords and a feature introduction and so on, and yeah, I'm sure you want to know how it actually works and what it looks like in practice. So here is a picture, an architecture picture, which you can also find online if you want to study it in detail. So important is that the blue boxes on this diagram are tools which are developed in Project Syn. The green boxes are Git repositories which store information, different kind of information, and the white boxes are upstream tools which are in use here. So the most important component here is the Lieutenant. That's the inventory API which stores all the information about your Kubernetes clusters, and it also takes care of managing Git repositories, at this time in GitLab, but it could also do this in GitHub or in GT or other Git hosting repository software. Then we have Commodore. Commodore is the configuration generator. This tool uses Capitan in the backend to actually do the hard work, and it is mainly a wrapper around it. It connects to Lieutenant, collects all the information about the cluster, feeds this information into Capitan, and then generates configuration files. These configuration files are then stored in a Git repository per cluster. So each Kubernetes cluster has its own Git repository storing all the YAML files which are actually generated for this particular Kubernetes cluster. On the cluster itself, we have Argo CD running. Argo CD will then fetch these YAML files and apply it to the cluster and make sure this configuration is available. Inside of the cluster, we have the steward. Steward is the in-cluster agent which enables Project Syn on a cluster. It's the bootstrapping tooling and also the babysitting tooling. It makes sure that Argo CD is always up and running. It has the correct configuration. And Argo CD on the other way around checks that steward is up and running and has the correct configuration. Initially, when the cluster isn't managed by Project Syn, steward will bootstrap Argo CD into the cluster, generates access secrets for the cluster catalog repository, and together with Lieutenant, make sure that the whole bootstrapping process is completely automated and you don't have to touch anything anymore. On the Git repository side, we have the common configuration Git repository. This holds configuration settings for all your Kubernetes clusters which are managed by this instance of Project Syn. Then you have another Git repository which stores information per tenant. That can be, as already told, a customer, a team, or a sub-team, or whatever you want to have as a tenant. And this Git repository stores the common configuration per tenant, but can also store configuration per cluster if you need that. And as you see, we also have Renovate, watching these repositories, making merge or pull requests whenever needed to update versions. And we have these Commodore components, which are stored on GitHub and can be used by the community. Also, we have Vault in the middle. Vault is used to store secrets securely. It is used by Capitan in the backend to retrieve secrets and to apply them directly on the cluster if needed. So that means no secrets are stored in Git, actually. In Git, we only store references to secrets. We not even store encrypted secrets. It's just references, and during the phase of apply on the cluster, the plugin in Argo CD for Capitan knows what to do with these references and retrieves them and applies them directly in the cluster without revealing them outside of a cluster. So secrets are completely contained in a Kubernetes cluster. Another deeper look into the operator, that's the lieutenant you have seen in the picture before. The lieutenant operator is there to implement automation as much as possible. So for example, if I register a new tenant, the operator automatically connects to, for example, GitLab and creates a Git repository and prepares this Git repository for later use. The same happens if you register a new cluster in Lieutenant. The operator automatically creates a Git repository for this cluster, which is then later used to store the catalog of all the YAML manifests to be applied on the cluster. It also takes care of, for example, configuring deploy keys on the Git repository. So you don't have to manually create the Git repository and grant access and all these things. This is all handled by the lieutenant operator. To access all this information, you can either use directly Kubernetes API possibilities, or there is a lightweight layer in between. That's the Lieutenant API. That's a RESTful API which allows for easy access to tenant and cluster objects to have an easier means of developing against this tooling. The core Project Syn tools are, as you have seen in the diagram, are the Lieutenant API, the Lieutenant Operator, Commodore, and Steward. These are the main tools which are being developed in Project Syn. And we also use a lot of third-party tooling. For example, Argo CD. Without Argo CD, the whole process wouldn't work. Also, Vault is very important to store secrets in a secure fashion. And Capitan is used to do the hard work for generating actually the configuration. We are also using Renovate, and we are experimenting with Crossplane for automated service provisioning in the cloud, but that's just in the experimental phase at this time. So now we have seen an overview of the concept behind Project Syn. And now we can have a bit deeper look into what's going on behind the scenes. First and foremost, the most important part of Commodore is the configuration hierarchy. So that means you have a possibility to define common parameters which are the same on all your clusters. And then, depending on the hierarchy, which is defined currently in the code, which can be configured in a later stage, you can override configuration parameters or add additional configuration parameters depending on the specs of your Kubernetes cluster. So as you see, the deeper you go into the hierarchy, the more specific the configuration is. So you're able to override on a tenant level, on a cluster level, or on a cloud provider level, depending on your needs. And this helps to have a common configuration across all your Kubernetes cluster, but also have a common configuration per customer or per cluster. This hierarchy is currently hard-coded. We are working on a feature to make this configurable at the end. So how does such a common configuration repository look like? You can browse to GitHub and have a look on your own. This is a Git repository consisting of several configuration files, and one of the currently most important file there is the commodore.yml. This specifies where all these components are stored. So you can store components on your internal Git repository hosting, or you can store it on GitHub. And with this file, you actually specify where these components can be found. So that during the phase of compilation, the tooling knows where to fetch these components. Then an example here, it's a bit small, but you can see it on GitHub as well. You see here, for example, a definition for a K3s Kubernetes cluster. And this one includes, for example, Argo CD and the metrics servers. But with this definition, you could also include other components as well, if you want. Then you can set parameters per component. For example, here you see we configured the API URL on the steward cluster, and this is now on the part where we can override parameters. So maybe you have a common configuration which says, hey, Lieutenant is available here, but for this particular cluster, it's available on a different place. How does such a Commodore component look like? It's mainly using the Capitan configuration structure, so it might be a good thing to know how Capitan works, and this also helps to understand Commodore much better. Commodore has a defaults file. This is here. This one specifies the default parameters for this particular component, which is used by the hierarchy on the top level. Then you specify some parameters for Capitan itself. This is the my component file here, and then as you see on the file ending, it's a JSONnet component. But Capitan also supports Helm charts, for example. So that if you already have a good Helm chart for your thing you want to install, you could also use a Helm chart and just parameterize it using Commodore. But we started to use JSONnet a lot. It helps you with a good amount of flexibility of developing such components. So that was a very quick introduction to the project itself. Usually you learn a lot when you do it yourself, not just by listening to some slides and stuff. So we wrote the Getting Started guide, which you can do on your own. It's a step-by-step guide. When you have done this, you have a full Project Syn instance up and running. It takes you around half an hour, I would say. And if you want to dive deeper, there is a whole lot of documentation already available. We wrote the full tutorial of how to write the Commodore component, because in the day-to-day business of managing Kubernetes clusters, most of the work goes into writing, adapting, and enhancing such Commodore components. We are currently at version 0.2. We are using it internally for a few initial test clusters, also a few production clusters. As usual, usually tests goes into production much faster than you think. But you are gaining experience with this tooling all day, and this also gives us a good input for the roadmap. And you can also see the roadmap on the website and see where you want to head. It's on GitHub. It's in its own Git organization. We want to open this project to outside contributors, so it would be cool to get some more help here. That was a short rush through Project Syn. If you have any questions, I'm happy to answer them, but we are also reachable on email. We have a chat channel, and yeah, that's it. Are there already any questions? Yeah.
So I'm guessing you started building this before Kubernetes, so more or less you were competing with Rancher.
No, so the question was if we are competing with Rancher?
No, basically if I would choose to build like a cluster fleet management, such as, let's say, multiple clusters being managed by one single cluster, yeah. Why would I use Project Syn versus Rancher, which exists for already a couple of years, right?
Okay. So the question was, why should I use Project Syn instead of Rancher?
Yeah.
So Project Syn focuses on configuration management. It focuses on assigning clusters to tenants. It focuses on an inventory service which brings you much more information than Rancher. It doesn't compete, it enhances Rancher. We are also using Rancher internally for managing Kubernetes clusters. We use it to spin up Kubernetes clusters, spin down, monitor them, and so on. But we use Project Syn to actually deliver configuration to many clusters, which are much more powerful than what Rancher can do today.
But when you don't manage user access with Project Syn, do you?
No. So the question was if we manage user access to the Kubernetes clusters. No, this is done by Rancher. Okay. Yes. Yeah. Any other questions?
When did you start working on Project Syn?
So the idea is about 1.5 years old, and actually the development or the research started in November last year, I would say, and actually the development part started in February this year. Yeah.
Perfectly timed on the whole COVID situation.
Oh, yeah. Okay. Thanks.
Thanks.
Do you want to take over?
Yeah, and it's the last chance to ask some questions here in the chat. So if you have any questions from the audience remote, please write in the chat. Here, Tim, how do you get your existing clusters into Syn?
Okay, so how do we get our existing clusters into Syn? So we register them in Lieutenant, so we make them aware. We make Lieutenant aware of the cluster, and then we apply steward to the cluster. Okay. When you register a cluster in Lieutenant, it automatically generates an apply URL for you, which includes a short-lived secret. So the output of the register command is that you get a kubectl apply -f URL, and if you do that, it installs steward, and it knows already all about where the catalog repository is. It knows all about how to bootstrap Argo CD, and then magic happens in the end.
Cool.
Good. Any
So thank you very much for listening, and if you have any feedback on improving our streaming setup, please approach me. So there was one minor issue with the sync of the stream, so I restarted it and it worked.
Okay.
So,
cool.
Okay, thank you. Then goodbye.
Thank you.